Welcome to myprojectbazaar.com. Now we can going to discuss about the project multifunctional DC's electric spring for improving voltage quality for DC grids. Now we can going to discuss about the abstract of our project. An electric spring is nothing but we can use the own system to one system to process out this intermediate section to use an electric spring. The electric spring process is to reduce the frequency fluctuations and the harmonics detections and the noise levels and reduce the electric spring levels. So we can this paper extract the concept of development of DC electric springs for voltage regulation for emerging DC power grids. The configuration of series and shunt active for respective for operating modes is explained detailed. Both types electric springs are their functionalities of DC bus voltage regulations and double line frequencies harmonic compensation provided the fault rate through the support are discussed. This shows good agreement with the theoretical analysis confirm the DC electric spring can be efficient solution provided the simulation functions of DC microgrids of voltage regulation. As electric spring has been proposed, the distribution demand response to the magnetic voltage and the frequency fluctuation of AC power system fed to the substantially intermediate renewable energy systems. Now we can going to discuss about the flow diagram of our project. First we can see about the solar panel. The solar panel input of irradiance. We can by example we can take the 100 irradiance or 80 or 500 800. We can use the different irradiance. We can use that the solar panels. The solar panel is a DC power output. So we can send to the DC power output in the maximum power point tracking technique. This is one of the prestigious technique of the solar panel. So we just process the high maximum power we can generate the solar panel. Again it passes to the DC to DC boost converter is an maximum power of the solar panel. We get the booster level of the solar taken. Next we can pass to the common DC bus. This is a common DC bus. The DC bus can only for a DC voltages and current. So it passes to the this program used for series electric spring can used or but our base power can tell that series and shunt electric spring can be used, but this flow diagram can tell only for series electric spring. The electric springs are one of the transmission process of the AC frequency fluctuations. So we can use the series electric spring is passed to the DC to AC converter. So this is one of the conventional process use of the IGBT switches used the different switches. So we can use of switching pulse of the pulse generator can use that. So is transmitted to the intermediate section of the linear and non-linear loads. You can use the different types of loads, linear and non-linear. Linear load is purely resistive load. Non-linear load some resistive plus inductive or resistive plus capacitive. We can add the different types of combinations that we can run flows of these loads. So again we can these levels are reduce that intermediate section. Some we can use the different types of filter. We can use that. We can example we can take the LC filter or ripple filter or RL filter. We can use the different filters can as well to reduce the harmonics level of the this conventional levels. So we can store the AC grid of the our conventional AC power. We can also utilize or store the energies to the AC power. Next we can going to discuss about the running process of the project. The proposed system implementation done in MATLAB version 2013A. First you open the MATLAB file window and create a new model file. After creating elements as per the circuit diagram, and after creating elements for corresponding scopes are collected in the circuit diagram of the project. So we can see about the circuit diagram of the project. This is an shunt electric spring in this portion blue color. So we can process are different. This is shunt and another for series. So we can use two topology diagrams, but we can running process of this. We can only for running the shunt diagrams. So I can show the all results of shunt process. First this we can see the PV characteristics of the solar panel. for a DC electric spring. This is an PV characteristics. Another is an IV. This is an IV characteristics. This is an exceeding the range. So this is not the plotted this graph. Next we can see the output, battery output. This is an battery to discharge the discharge ranges, and voltage current also decreased. Voltage also slag by upon waves on lightly also decreased because of we can discharge the battery. So you can see the electric spring voltage. This is an electric spring voltage for inner side of the shunt using the electric spring to harm voltage fluctuation, also linear process to integrated as electric spring. Next we can show that this is a critical load of load fluctuations. There is a lot of load fluctuation in these areas. So because of we can very lot of fluctuation in harmonics. So it's a very density wave. This is for critical load. Similar to that, critical and non-critical load are also very noisy and very high dense level waveforms. These are the switching pulse of the voltage source converter. Is a first switch is on and second switch is on off. Is randomly sequentially on and off, on and off. We can use that because of its control of the switch voltage source converter. Second is an PV system injected to the grid side is fluctuated. This one totally we can lot of noise get in the load, so we can possibly line this is a noisy voltage and noise current. This is our noise levels. Next we can see the voltage. We can receiving the AC grid. The AC grid doesn't purely get sinusoidal wave. So our harmonics also reduced using of the ripple filter and the electric spring process. This is our current of a 3-phase. Is an A phase, B phase and C phase. We can purely get a sinusoidal wave. No fluctuations and harmonics are not occur. This AC source